In this video, we are going to practice simplifying a radical that contains both numbers and variables. So let's look at our first one. If we have a square root on top of a number and a variable, technically, we can look at each individual piece. Now, the square root of 9 is just 3. Now, why is that? Well, 3 squared is 9. So the square root of 9 goes backwards and is 3. Now, let's take a look at this. There's a little number here that you don't see in a square root. When we think of the word square, we think of second power. There's a little number here called the index, and that index is a 2. So the square root takes any powers, kind of like we saw up here, and it reverses them by dividing the power by 2. So if we divide this power by 2, we get 1. Now, how can you check your work? Well, there's a quick little check. If you do 3x times 3x, or 3x squared, you should get what's inside. So you'll see we get 9x squared. So that's perfect. Okay? Now let's try one that's a little more complicated. In this second one, 20 is not a perfect square, but 20 is 4 times 5. Now, 4 is a perfect square, so that's going to help us. Now, remember, this index divided the power by 2 because we really are a square root. We're undoing a square. So 2 goes into 5, and it uses 4. It can go into 4, and it will have 1 left over. Now, the rules of exponents say that if the bases are alike and we're multiplying, we add the exponents. So I can break this apart like this. Now, why do I want to do that? Well, this part here is a perfect square. This part here is a perfect square. So let's evaluate those two pieces. So the square root of 4 is 2. The square root of x to the 4th, cut the power in half, that's x squared. Now, there are still some pieces that we have not evaluated. 5 and the x. Because those are our extra pieces, then they are not perfect squares. Just leave those pieces alone inside of your square root. And how could you check? Now, this one's a little weirder to check it, but we can check our work real fast. We should be able to multiply 2x squared like we did up here, how we took and multiplied it by itself. Let's see, let's do that a little differently. So if I do 2x squared times 2x squared, I get 4x to the 4th. And if I multiply it by the 5x that is stuck in there, I should get 20x to the 5th. And I do. So there is an example of two simplifying radicals that have both number components and also power components. Now, there is one little thing you'll see in some books. When the power, when you take a square root and there is a power that was even and that becomes an odd power, you can include like a little absolute value there. What the absolute value does is it just allows us to account for the fact that negative numbers aren't going to work right, so the absolute value can be put on there as well. Okay, there you go. I hope this helped. If this helped, please like, and if you could also subscribe to my page, that helps me make more videos. Thanks, bye.